Geotechnics. What is geotechnics? Geotechnics is a branch of civil engineering that studies the physical and mechanical properties of soils and rocks, as well as their behavior and response to applied loads. This discipline analyzes how soils affect structures and how their characteristics can be improved to ensure the stability and safety of constructions. Origin and evolution of geotechnics. Geotechnics has its roots in ancient times, when the ancient Egyptians and Mesopotamians built their monuments and buildings using empirical techniques based on observation and experience. However, it was in the 18th century that more rigorous studies began on the behavior of soils, with the arrival of the Industrial Revolution and the rise of infrastructure construction. Over the years, geotechnics has made great strides, thanks to the development of new soil exploration and testing technologies. This has enabled a better understanding of soil properties and has facilitated the completion of larger and more complex construction projects. The importance of geotechnics in engineering. Geotechnics plays a fundamental role in civil engineering as it provides the necessary knowledge for the design and construction of safe and durable structures. By studying soil properties, it is possible to determine the loads they can support, prevent settlements and slides, and ensure the stability of structures. Additionally, geotechnics is essential in the planning and management of infrastructure projects, as it allows for the evaluation of the feasibility of works and the conducting of environmental impact studies. It also plays an important role in sustainability, as it helps minimize the negative effects of constructions on the natural environment. Basic geotechnical concepts. Soil properties. Soils have a series of physical and mechanical properties that determine their behavior and load-bearing capacity. Some of the most important properties include granulometry, plasticity, permeability, and compressibility. These properties are determined through laboratory tests and allow the classification of soils into different categories or types. Soil behavior under load. Soils can undergo deformations and settlements when a load is applied. The behavior of soils under load depends on their stress state, density, moisture content, and composition. This information is crucial for the design of foundations and structures. Main geotechnical parameters. Geotechnical parameters are values used to characterize and represent soil behavior. Some of the most important parameters include shear strength, cohesion, friction angle, compressibility, and permeability. These parameters are determined through laboratory tests and in situ tests. Geotechnical investigation. Subsurface exploration methods. Geotechnical investigation is carried out through different subsurface exploration methods. Some of the most common methods are drilling boreholes, soil sampling, conducting in situ tests, and using geophysical techniques. These methods allow for obtaining information about the terrain's characteristics and its behavior under load. Soil sample analysis. Once soil samples are collected, they are analyzed in the laboratory to determine their geotechnical properties. Laboratory tests include granulometry, Atterberg limits, compressibility, shear strength, permeability, and others. These analyses allow for the classification of soils and the acquisition of the parameters necessary for the design of works. Interpretation of geotechnical results. Once the geotechnical investigation is completed and test results are obtained, the next step is interpretation. This involves analyzing the obtained values and determining the characteristics of the terrain, such as load-bearing capacity, slope stability, or permeability. These results are essential for the design and construction of projects.